Well, the fine-tuning of the laws and the constants of physics and the initial conditions, that is the arrangement of matter at the beginning of the universe, is one of the most extraordinary discoveries of the 20th century in physics. It started in the 1950s with a man named Fred Hoyle, a prominent British astrophysicist, now Sir Fred Hoyle. And Hoyle discovered that the conditions that were necessary to make it possible for carbon to form in the universe were incredibly improbable, and there were many conditions that had to combine to make it possible for lighter elements, in particular beryllium and helium, to combine to make carbon. It also was apparent to Hoyle and many other scientists that we need carbon because carbon is a molecule that allows long chain-like molecules to form, and it's necessary for storing information, which is a critical condition for life. All life is carbon-based. People have speculated about life being silicon-based or something else, but Hoyle and other physicists who knew the score knew that that wasn't a serious proposal. And so it absolutely shocked Hoyle when he discovered how many different parameters had to be just as they are in order for carbon to form. Carbon forms in the center of stars through a process known as nuclear synthesis. If the gravitation inside stars is too weak, then the temperature of the star won't get hot enough so that the beryllium and the helium will combine to form carbon, beryllium and helium being lighter elements. If the gravitation is too strong, however, the star will simply burn up before those critical reactions can take place. And that was only one of a whole suite of exquisitely finely tuned conditions that had to be just right. And when they did the mathematics on this, when they calculated how finely tuned these parameters were, they were getting numbers that were 1 in 10 to the big exponential numbers in each case. So it's a kind of a concept like in engineering of tolerances. Things have to be within very narrow bounds in order for things to work. So in order to get a life-friendly universe, we're kind of in what you might call a Goldilocks zone, where multiple parameters, now we know about 36 of these, the expansion rate of the universe, the strength of gravitational attraction, the ratio of fundamental forces like the electromagnetic force and the strong nuclear force, all of these, the strength of these forces have to be just right to allow for life to exist in building carbon, having stable planets and galaxies. Many, many conditions of life depend on these fine-tuning parameters being just right. And so you can think of it as a Goldilocks universe. Not too hot, not too cold, the force is not too strong, not too weak, speed of light not too fast, not too slow, expansion rate of the universe not too rapid, not too... So things are just right. And this has caused many physicists, Hoyle in particular, to shift their perspective on the big worldview questions. Hoyle was an atheist who resisted the discovery of the Big Bang because he thought it implied a creation event, came up with an alternative theory that was later refuted called the steady state theory, but then after the fine-tuning realized that there must be some design behind the universe. And he said a common sense interpretation of the data suggests that a super intellect has monkeyed with physics and chemistry to make life possible. So that's what the fine-tuning is about. It's a powerful evidence of design that's come out of physics. The evidence of the exquisite fine-tuning of the laws, the constants, and the initial conditions of the universe have suggested to many physicists that the universe is a setup job, that it was finely tuned because there was a fine-tuner who chose the parameters. A popular alternative explanation for the fine-tuning is the idea of the multiverse. The multiverse acknowledges that the conditions necessary to make life in this universe are incredibly improbable. But it posits the existence of multiple billions of other universes that would, in toto, make the conditions necessary for life likely somewhere. And then there's the additional assertion that, well, we just happen to be in that lucky universe. And so the multiverse tries to expand what are sometimes called the probabilistic resources. If just one universe isn't enough to render the incredible fine-tuning probable, well then let's posit a whole bunch of others so that at some point the conditions just must have had to have arisen. Now, in order to make that explanation work, multiverse advocates realize that there needs to be some connection between these different universes. If all the other universes out there have no connection to our universe, then whatever happens in those other universes doesn't affect the probabilities in our universe. So in order to portray these multiverses as the kind of outcome of a cosmic lottery, multiverse advocates have realized they needed to posit some kind of universe-generating mechanism that would, in a way, provide a common causal connection between all of them. All of the universes have sprung from the same mechanism, and then we can think of our universe as just one of many outcomes of a kind of lottery. Now, and this is where the problem comes in for the multiverse, because it turns out that every mechanism that's been proposed, whether something out of a cosmology called inflationary cosmology or a mechanism from what's called the string theoretic landscape, every mechanism that's been proposed to explain where these new universes come from has itself required prior fine-tuning. Theoretically, you just don't get this great variety of other universes unless there's something fine-tuning the mechanism. So the upshot of this is that the multiverse explains the fine-tuning only by reference to invoking prior unexplained fine-tuning, and so in the end you're left right where you started. You haven't really explained the fine-tuning that makes life possible in our universe, or for that matter anywhere else. One alternative explanation for the fine-tuning of the laws and constants and initial conditions of the universe is the idea known as the weak anthropic principle. According to the weak anthropic principle, we shouldn't be surprised to find that we live in a universe that has conditions which are conducive to our existence. After all, we're here. And since we shouldn't be surprised by the discovery that we live in a universe that has conditions that are conducive to our existence, there's nothing to be explained. No surprise, no need for an explanation. Now, the problem with this alternative explanation is that it really fails to reckon with the thing that really does surprise us and which is really does need explanation, and that is the incredible improbability of the conditions that are necessary for our existence. We shouldn't be surprised to discover that there are conditions that are conducive to our existence because after all we're here, but we can be very surprised to discover that those necessary conditions of our existence are so incredibly improbable. Here's an illustration that gets this across. This is from the philosopher of science John Leslie. Imagine you're standing before a firing squad of trained Nazi marksmen, and they've found that you've been caught in a plot to kill Hitler or something. Anyway, the order comes, ready, aim, fire, and suddenly there's a barrage of bullets, and you are behind your blindfold, but the noise stops, and you discover you're still alive. And then you turn around, take the blindfold off, and there's a pattern of bullets that circumscribes your body, but none of them hit you. Now he says, of course, says Leslie, you should. What should you think in that place? Well, of course, he says, you shouldn't be surprised to find that you live in a universe that's that has conditions that are consistent with your existence. But you should be surprised that you're still alive because those conditions are so improbable in relation to what you know about the skill of the marksman and how many of them there were firing at you. So the weak anthropic principle doesn't really explain what needs to be explained, which is not just conditions that are consistent with our existence. It needs to explain the improbability of those conditions, and that it fails to do. Another problem with the weak anthropic principle idea is that it confuses a necessary condition with a causal explanation. In particular, our need for a causal explanation of the incredibly finely tuned and improbable conditions that are necessary for our existence. To illustrate, imagine there's a fire in your city and the insurance company sends out an investigator to find out what caused the fire to occur. The investigator goes out and he sees, well, there's some matches, there's some old gas cans, there's some little sprinkles of extra gas on, and a lot of charred buildings. But he doesn't really take any note of that. Instead, he comes back and he files his report and he tells the insurance company, well, I know what caused the building to burn down. It was the oxygen in the atmosphere. They say, what? Oxygen? Yes, oxygen, he says, is a necessary condition of fire. You can't have a fire without oxygen. Well, what's his mistake? Well, he's confused a necessary condition with a cause or a sufficient condition or a set of sufficient conditions. And really the cause was, in this case, arson, and he overlooked all the clues. Well, this is effectively what the weak anthropic principle does. It says, well, here's we are citing a necessary condition of our existence, all these fine-tuning parameters. What more do we need to explain why we're here? Well, what we really want to know is not just what the conditions are. We want to know, and whether they're necessary or not, we want to know what caused those conditions to come into existence that would explain jointly why life is present. And that the weak anthropic principle doesn't do. What we need to know instead is a causal explanation. Design provides that explanation because it tells you why the conditions were set and why they're so incredibly improbable. The weak anthropic principle doesn't. One of the great discoveries of the 20th century that has challenged materialism as a philosophy at a fundamental level is the discovery that the universe had a definite beginning. In fact, the material universe is now thought to have had a definite beginning, that if you go back far enough in time, the curvature of space becomes infinitely tight, corresponding to zero spatial volume. That's a consequence of a theorem known as the singularity theorem that Stephen Hawking and Roger Penrose proved in 1968. It was a consequence of their solving Einstein's gravitational field equations, reflecting his theory of general relativity. So this is a mind-blowing conclusion in modern cosmology. There was first the discovery that the universe is expanding outward in every direction of space because of the red-shifted light coming from distant galaxies, and then theoretical considerations from general relativity also reinforce that idea, showing that the universe, the material universe itself, had a definite beginning. Even time and space began. If there's an infinitely tight curvature of space, that suggests that there's no place to put any matter, and so you have a fundamental challenge to the materialistic worldview or the worldview of scientific materialism. Now, beginning in the 1980s, late 80s, Stephen Hawking and other theoretical physicists, Hawking, who was involved in the 1968 proof of the singularity theorem, didn't like that conclusion too much, began to think of some other alternative explanations. And Hawking came up with something called quantum cosmology, which he popularized in a book called The Brief History of Time, which he published in 1988. I was a PhD student at Cambridge at the time, and actually attended the series of lectures that Hawking gave that became the little book, The Brief History of Time. Anyway, since the late 80s, there's been this idea that the laws of physics by themselves can explain the origin of the universe from literally nothing, and that therefore there's no need for any kind of external agent or creator, no transcendent cause of any kind, that the laws of physics alone explain where the universe came from. So whereas in the early 80s, there were books coming out like God and the Astronomers by Robert Jastrow, and other major figures in astronomy were saying, hey, look, this Big Bang theory, this singularity theorem clearly has theistic implications. It's pointing to the need for a cause that transcends matter, space, time, and energy. Who does that sound like? But after the 1980s, this quantum cosmology idea has caught on and has seemed to kind of neutralize the implications of the Big Bang, at least with respect to being affirmative of theistic belief. In fact, many of the new atheists have taken up quantum cosmology as their go-to explanation for how you get a universe without God, one of those being Lawrence Krauss. Now, I've gotten more into quantum cosmology in the last couple of years, and it turns out there are a couple reasons to doubt that this idea of invoking the laws of physics, the laws of quantum physics, can explain where the universe came from in the first place. The first is that this whole research program misunderstands what laws do. Laws don't explain where matter and energy come from. Laws describe how matter and energy interact once they exist. They don't give you an origins explanation. They describe the ongoing behavior of the entities within the universe. So that's a fundamental philosophical problem. Secondly, a law of physics is expressed mathematically as an equation. And those equations exist in the minds of mathematicians and physicists. They don't actually exist in nature. Our laws describe the behavior of material entities and energy and so forth, but they don't in any way cause things to happen in the material world. So to say that the laws of quantum mechanics cause the universe to come into existence is a strange kind of category error. It's like saying the latitude and longitude lines on a map are responsible for the rise of the Himalayan mountains. The map describes where the mountain is, but it doesn't tell you how the mountain got here. Now, there's one final problem, and this is the one that I think is most profound. The quantum cosmological model wants to describe our universe as a reasonably probable outcome of something called a quantum mechanical wave function. It's often represented with the Greek letter psi. So psi is a function that describes all the possible gravitational fields that could be instantiated or exemplified by our universe. Gravity, in Einstein's view, is curved space as a result of the concentration of matter. So this universal wave function describes all the different configurations of matter and all the different shapes of space that the universe could have. And it becomes an origins explanation when that wave function includes our universe as one of the reasonably probable outcomes of all those possibilities. But here's the problem that I discovered. In order to get a quantum mechanical wave function, you have to solve a prior quantum mechanical equation, something that's analogous to the Schrödinger equation in ordinary quantum mechanics. But the physicists themselves tell us that you can't solve that equation unless you apply a number of what are called boundary constraints, which are limitations on the mathematical degrees of freedom expressed in that equation. Or another way to put it is the equation is insoluble without the imposition of boundary constraints. But who imposes the boundary constraints? Who restricts the degrees of mathematical freedom, the possibilities that could exist? Well, it's the theoretical physicist. Now, anytime, and this is basic information theory, anytime we say we exclude one option and elect another, we're imparting a bit of information. So if there are an infinite number of solutions to this prior equation, and that's what the physicists tell us, then you have to supply a huge number of boundary constraints to make the equation soluble, and that means you have to supply a huge amount of information. And in the mathematical modeling of the origin of the universe, who supplies that information? The theoretical physicist, the intelligent agent. So even in cosmology, it now appears that there's an information problem that's only solved in our modeling by an intelligent agent choosing some boundary restrictions, boundary constraints, and limiting the mathematical degrees of freedom in various ways to generate a wave function that includes our universe as a reasonably probable outcome. So you've got multiple problems with this quantum cosmology, but the deepest one is that it's actually modeling the need for information to give you a finely tuned universe. So one of the major discoveries of the 20th century in biology was the discovery of the structure of the DNA molecule, or the elucidation of the structure of the DNA molecule. And that occurred in 1953 when Watson and Crick determined that the DNA had a double helix structure, along the inside of which were these 4 chemical subunits called bases, or nucleotide bases. And then 4 years later, Crick took that discovery one step further and realized that those chemical subunits on the inside of the molecule were functioning just like alphabetic characters in a written language, or digital characters like the zeros and ones we use in software. In other words, it wasn't the structure of those, the chemical structure of those subunits, or their molecular weight, or their shape that mattered. What mattered was their arrangement in accord with an independent code that was later discovered called the genetic code. So inside the DNA molecule, what we have is literally information or instructions inscribed digitally or alphabetically, typographically, in a way that provides the information that's necessary to build the important proteins and protein machines that keep all cells alive. So this is a stop-press moment in the history of biology. People have wondered for centuries, why does like beget like? And at least in the case of why we get new proteins that are like the old proteins, the question or the answer is the DNA contains the information for building them, and that's what keeps living cells alive. Well, we're here in Seattle, and we have a lot of great companies here, especially tech companies. And we've got the famous Microsoft company that writes code in the form of software. We also have the Boeing company and other companies that use a technology known as computer-assisted design and manufacture. And that's a technology where information in a digital form is used to direct the construction of mechanical parts or physical systems. So if you're a Boeing engineer, you might sit at a console and write code. That code will go down a wire. It will be translated into another machine code that can be read at a manufacturing arm or center, and then that information will be used, for example, to take rivets and put them on the airplane wing at just the right place. So you have digital information directing the construction of a mechanical system. Something very much like that is going on inside the cell, where the information inside DNA is being used to direct the construction of the proteins and protein machines that are necessary for all cellular life. Natural selection and random mutation don't seem to be a very good explanation for the origin of new genetic information. And the reason for that can be understood by reference to our own experience with digital code, with software. If you're a computer programmer, you know that if you start randomly changing the sections of functional code, you're going to degrade that code long before you ever come up with a new program or operating system. And the same thing applies in the biological case, because the information in DNA is essentially digital or typographic. And because there are far more ways to arrange those A's, C's, G's, and T's along the DNA molecule that will result in gibberish than will result in functional information capable of building a new protein. Inevitably, as random changes accumulate, they're going to find those non-functional combinations. And the process of evolution is going to have, or the process of natural selection is going to have nothing to select. Remember, natural selection can only select for functional advantage. If the code is degraded by random mutations before you ever get to something new and functional, then the evolutionary process is going to terminate. So the natural selection random mutation process is very good for preserving existing function and existing form. It can preserve slight variations on that form, but it can't generate anything fundamentally new. And that's why you have a lot of evolutionary biologists themselves today saying things like natural selection and random mutation can explain the survival, but not the arrival of the fittest. They explain the small-scale variations or changes, but they do not explain where major innovation comes from in the history of life. All right, the reason that random changes inevitably degrade the information in a DNA sequence is the same reason that random changes inevitably degrade information in a section of computer code or English text. For every sequence of 12 letters in English language that does convey a meaning, there are 100 trillion other possible ways of arranging those same characters that don't. And the same thing turns out to be true in the DNA protein case. For a modest protein of about 150 amino acids long, for every sequence that produces a functional protein, there are about 10 to the 77th other possibilities that don't. And what that means is then there's a huge search space that has to be searched by the random mutation mechanism to try to find the functional sequences in that vast array of possibilities. And it turns out when you do the math, there isn't enough time, even assuming a 4 billion year history of life on this planet to have enough replication events, enough copying events to search that space effectively. You're going to end up with a tiny, even if all of those, every time an organism replicates from the beginning of the first life till now, a new mutation occurred searching for a new protein, you'd only search a tiny fraction of the total number of possibilities. And so it becomes much more likely that such a random search will fail than it is that such a search will succeed. The bottom line is the neo-Darwinian mechanism is just not a plausible mechanism for generating new functional biological information. As it's become clear that the various evolutionary mechanisms do not account for the origin of genetic information, naturally people have wondered, well, what might? And we've proposed an alternative explanation, and that is the idea of intelligent design. And the reason that intelligent design provides a good scientific explanation for the origin of the new information necessary to build new proteins and new forms of animal life is that we know from our experience that information always arises from an intelligent source. Whether we're looking at hieroglyphic inscription or a paragraph in a book or information in a section of software code, or even information embedded in a radio signal. Whenever we see information and we trace it back to its source, it always comes to a mind, not an undirected material process. So the discovery of information at the foundation of life and the discovery that big infusions of information are necessary to explain the origin of new forms of life suggests the activity of a designing intelligence in the history of life. The inference to intelligent design is based on our uniform and repeated experience of cause and effect, which is the basis of all scientific reasoning. We know from experience not only that the neo-Darwinian mechanism and other similar, more recent evolutionary mechanisms that have been proposed have failed to generate the information, the digital and functionally specified information necessary to build new proteins and new forms of animal life. We also know that there is a cause, we know of a cause that does generate functional digital code or digital information, and that cause is intelligence. And we have experience of that in our own realm of software technology or our human experience. In fact, here locally, our hero Bill Gates has said that DNA is like a software program, only much more complicated than any we've ever created. Now, what we know from experience is that it takes a programmer to make a program, to make a computer program. In fact, more generally, we know that whenever we see information, whether it's a software program or a hieroglyphic inscription or a paragraph in a book, whenever we see information and we trace it back to its source, we always come to a mind, not a material process. So the discovery of information at the foundation of life in every living cell of every organism, and the evidence of big infusions of new information coming into the biosphere in the fossil record, both suggest that a designing intelligence has played a role in the construction of the information necessary to life throughout the history of life. And so the inference to intelligent design is not just an argument from ignorance. It's not just we're not just saying that, hey, natural selection and random mutation can't generate new information, or various chemical evolutionary processes have failed to explain the origin of information. We're also saying we know of a cause that does produce information. That cause is mind, and therefore, based on that positive knowledge of cause and effect, we can infer intelligent design as the best explanation, because in fact it's the only known cause of the generation of functional information, especially in a digital or in an alphabetic form. One of the great information scientists of the 20th century said, the creation of new information is habitually associated with conscious activity. That's what we know, and therefore the inference to design is a really strong inference from what we know, both about the facts of biology and about what it takes to generate information. A lot of scientists, because of the influence of materialism, are in a way inured to the reality of their own minds and therefore of minds in general. There's a kind of computer simulation known as a genetic algorithm where evolutionary scientists try to show how the mutation selection mechanism would work and they do this in a computational environment. They write a little program, they try to get something that simulates mutation and selection to generate a particular sequence of characters, or a phrase from Shakespeare was Richard Dawkins' preferred way of doing it. Methinks it is like a weasel. But in order to get the computer to generate the sequence, Dawkins has to first give the computer the sequence, and then he writes the program, his computer program, in such a way that as different randomized crops of letter strings are generated, the program selects the ones that are closest in function, or that are closest to the future function that he wants. Now, none of the original strings have any linguistic function at all. They don't have any meaning, but the program selects the ones that are closest to the future function that's desired. So he's selecting for proximity to future function, not actual function. Now that's problematic because natural selection selects for functional advantage. It doesn't have foresight to tell you what might eventually result in some future function. So the program that Dawkins generates is not actually analogous to what's going on in biology at all, or how the natural selection mechanism must work. But notice also, the extent to which it does work is entirely a function of his own mind, his own intellect. He gave the program the target sequence. He programmed the computer to select for proximity to future function. So these genetic algorithms invariably end up illustrating the need for mind to generate information. A similar thing happens with what are known as ribozyme engineering experiments. There, chemists attempt to generate RNA molecules that are capable of copying themselves, and thus could conceivably get something like natural selection going, because there would be an element of self-replication. The problem is that as the RNA chemists, the ribozyme engineers, have done their work, they've had to sequence the RNA molecules in very specific ways to get any copying capability out of them at all. As it turns out, they've only been able to generate RNA molecules that can copy about 10% of themselves. But even that limited self-replication capability is the product of intelligence, because it was the intelligent agent who essentially, nucleotide base by nucleotide base, determined the informational sequence that the RNA molecule or RNA ribozyme has. So again, what's being simulated? Well, it appears to us that what's being simulated is the need for intelligence to generate information. So far from the idea that intelligent design is the only known cause of information, and that far from the idea that the connection between intelligence and information is only a kind of common sense thing that has no scientific basis, we actually see that the attempt to simulate evolution is providing additional scientific basis for that connection. A lot of people reject the idea of intelligent design because they think that if you invoke the activity of a mind, you're invoking some unintelligible entity of which we have no real knowledge, or an entity, the conscious mind, which is not materialistic. But in fact, I want to argue that we know that we have conscious minds. We know our own consciousness better than we know anything else. In fact, all of our knowledge of the world around us is mediated to us through our senses and comes to us in our minds. So if the mind isn't a real entity, then we don't have any knowledge, let alone scientific knowledge. So mind is presupposed in all scientific inquiry. And getting rid of the mind as an explanatory entity is contrary to everything we actually know. We know from direct introspective activity, better than we know anything else, that we have minds, and we also know from our introspective activity the causal powers that our minds have, what our minds can do. And one of the things we know our minds can do is generate information. I'm doing it right now as we're speaking. So mind is a real entity. It's part of the world, and we've become inured to its reality. But it does really exist, and a good science will open itself up to all that takes place in the world, all the causes that are at work, including mental or conscious causes that are generated by minds.